speaker is Luis Carlos Basalo Crispino from the University of Pará in Belém, in Brazil. And he's an expert in many things and has a passion for the history of science and general relativity in particular. And today he's going to tell us about gravitational light deflection from a historical perspective. So Luis, go ahead. Thank you.
So thank you very much, Gonzalo, for the opportunity to speak here today. I would like to say that it's a very important initiative in these days of pandemic, and we are all going through very delicate moments in our countries, in our lives, and to have this opportunity to get together to talk about the works we have been doing and discuss and perhaps find new ideas and new roads for our research. This is wonderful, and I would like to thank you and all the organizers involved in this initiative. I would like to say that I don't know if you can see, but so the t-shirt I'm wearing now, I put especially in homage to Valencia University, right? That a gift I had from my friend Gonzalo. So I'd like to show that. I'd like to say also that it's very early in the morning in Brazil, so it's just about 6 o'clock. Okay, so let me go ahead. Gonzalo, just how much time do I have? How many minutes do you think I can?
It's a maximum of 50 minutes, but remember that we would like to have some discussion, if possible.
Perfect. So, okay, so let me go ahead then with the presentation. So as Gonzalo said, I would like to talk about, give my own historical perspective, right, of gravitational light deflection, mainly based in recent works that have been done this year. Although, I mean, I'm going to tell you about things that I've been interested in the last few years, but I think the two main things that I'd like to talk about, the novelties, are this work published in Nature Astronomy together with Santiago Paulo Antonio, and this work that has been published in International Journal of Modern Physics D this year. So this story, as you're going to soon realize, right, is a story about eclipse, and I should not, I have to say that today, as a coincidence, right, we didn't plan that. It's a very special day because we have a total solar eclipse that's going on in a few hours from now. But unfortunately, neither me in the north of Brazil, neither people in Valencia, well, not so many people in the world. So this total solar eclipse is only going to be seen in the south of Chile and in Argentina. Okay. As you all know, I mean, so in the mid-19th century, there was a triumph of Newtonian celestial mechanics, especially one of these very special occasions happened when Urbain Le Verrier, observing the orbit of Uranus, just realized that there should be another planet perturbing the orbit of Uranus, and he just computed theoretically where this other planet should be, and wrote letters, one letter specifically to the Berlin Observatory, this was in 1846, and said, look, point your telescope to a certain direction that I'm giving you the coordinates that you're going to find a planet. And then in the same night, amazingly, Neptune was discovered. And this was really wonderful, and I'll say a moment of triumph of Newtonian celestial mechanics. And okay, I mean, this went on, and this same gentleman, Urbain Le Verrier, observing the orbit of Mercury, found some anomalies, and then he also thought that maybe there should be one or more than one planet around Mercury's orbit that would cause these perturbations. And this was around 1860s, more or less. And in fact, astronomers passed like many decades looking for this supposed planet. They even have a name for it. It was Vulcano, that has never been found. And well, one of the occasions that the planet could be found, well, was during total solar eclipses. But every time that they had transit of Mercury in front of the solar disk, they could do more precise computations of the perturbations in Mercury's orbit. So we have some outreach activities. In one of these outreach activities in 2019, last year, we observed a transit of Mercury, as you can see here. And the next Mercury transit is going to happen only in 2032. So as I said, so this story is about the search of, starts with the search of intramercurial planets that could cause the perturbation in Mercury orbit. And obviously, apart from the possible transits that these planets will perform, supposed planets will perform in the solar disk, solar eclipses, especially total solar eclipses, would be very good occasions to look for these planets. And I will point 2 or 3 eclipses here in which this intramercurial planets, this search was performed. And the first one I'm going to point out is this 1869 total solar eclipse that was seen mainly in the United States, but also in Asia. And then there was 1869, around 1869, where was an occasion where photographs were, becoming very popular in the US. And so there were many expeditions organized to observe and photograph this total solar eclipse. And this is a newspaper putting some emphasis in this Harvard astronomical expedition to Kentucky to observe the total solar eclipse. And here in the left you see a photograph, and in the right you see a drawing, a very beautiful drawing of the solar corona during this total solar eclipse. And here you see, for instance, people together in Iowa in the United States. And as I said, so photograph was by that time popular, and many photographs were made of this total solar eclipse. And people even went to very, faraway sites just to get better locations to observe the eclipse. For instance, this hut that has been made specially to observe the total solar eclipse. And this is a group that got together in Iowa to observe the total solar eclipse. And the special thing about this photograph is that you can see Maria Michel, that is one of the that is the pioneer women in astronomy in the United States. So around 10 years after that, another total solar eclipse that I would like to point out for you is this 1878. So by this time, the search for intramercurial planets was very intense. And you see in this picture, in particular, more to the middle, James Watson, that was an astronomer from the University of Michigan, that were there to search for intramercurial planets. You can see many telescopes, not only here, but also here inside, to photograph the occasion. And in fact, James Watson, who unfortunately died some months after that occasion, died thinking that he has indeed observed intramercurial planets in that occasion. Just for curiosity, in this picture, you can also see Thomas Alva Edison. And here also again, Maria Michel, that with her women students observing this total solar eclipse. Now coming to the 20th century, one important solar eclipse was the 1900, May 28, 1900 total solar eclipse. That one important thing about this eclipse is that the field of stars coincided where the sun was going to be eclipsed around, right? Was the same star fields of the 1919 eclipse where general relativity was first confirmed. Total solar eclipses are really very popular where they can be seen. These are pictures in Europe, in Africa, and in the United States. But two main observatories were, leading at the time. One, obviously, was the Greenwich Observatory. So I put here some images made during the 1900 total solar eclipse. And the team of the Greenwich Observatory that went there was the Astronomer Royal William Christie at the time, assisted by Frank Dyson and Charles Davison. And here's an image of the Greenwich Observatory in 900 and in 2000. But another observatory that was leading the search, the astronomical search in research at that time, was the Lick Observatory in the United States, directed by William Campbell. And this was this picture was made of the observing site of the Lick Observatory, and the observations were performed by William Campbell himself, Charles Perrine, and Herbert Curtis. And this is a picture of the Lick Observatory in Mount Hamilton in California in 900. So searching for intramercurial planets, these astronomers just went around all over the world hunting, this total solar eclipse, hunting these intramercurial planets. And this is, for instance, the 1901 total solar eclipse that Curtis and Perrine, an astronomer observer that's going to be important in our story, went to Sumatra in the Dutch East Indies. And can you imagine, how the journey of this gentleman to arrive in Sumatra, right, to observe the total solar eclipse. And this picture is interesting, although you cannot see the cameras themselves because they are inside the hut, right? But these are the intramercurial planets positioned to try to find intramercurial planets in 1901 total solar eclipse. Another solar eclipse is 1905 that could be seen both in the North America and both in Europe. And in particular, you see this postcard of the illustrating the total solar eclipse from an observation site in Barcelona in Spain. And in 1905, the Greenwich Observatory went to Sfax in Tunisia to try to observe the total solar eclipse. But their main objectives at that time was to study the corona spectrum and properties, general properties of the solar corona. They were not specifically searching for intramercurial planets at that time. This was not the case of the Lick Observatory that in 1905 went to Alhama in Spain to try to find intramercurial planets. And another very interesting occasion was in 1908 in the total solar eclipse of January 3, the 3rd, in which Campbell and Perrine went to Flint Island in the middle of the Pacific Ocean. This was quite a journey, imagine, without a GPS or anything, for them to try to find intramercurial planets. So you see, these are the cameras. There were special cameras used to find these intramercurial planets, and you see them here in Flint Island. After they could not find any intramercurial planet in 1908, in particular, the Lick Observatory director, William Campbell, decided to put this quest to find Vulcan or any intramercurial planets aside and just forget about that. And then 1 year after that, Charles Perrine went to Argentina to run the National Argentinian Observatory. And this intramercurial intramercurial cameras that I just showed you the picture in Flint Island turned out to be the Einstein cameras. And why it is so? Because of Einstein's relativity. Obviously, to this audience, I don't have to explain anything about Einstein's relativity, right? But let me just mention that as you all know, I mean, it started in 1905 with this famous Einstein paper on the dynamics of moving bodies, right? Establishing the principles of special relativity, and with the idea of space-time itself being born thanks in the beginning to Hermann Minkowski. And then space-time became the arena of physics that we all understand very well. And there was Newtonian's gravity, right? That I was saying, that I just started by saying that it was triumphing, right? And then, but the problem was how to make it compatible with special relativity. Mainly, as you can see, I mean, you all know Newtonian's gravity formula, and you see there's no time, and then it leads to the idea of the instantaneous action at a distance, right? That is not compatible with special relativity. So you have to reconcile Newton's theory with special relativity. And one very important role was played by the free fall and what we know as the equivalence principle that establishes an equivalence between gravitation and acceleration. And this very important paper published by Albert Einstein in 1911 named On the Influence of Gravitation on the Propagation of Light. So the idea, well, think about a rocket, and you have like a light ray. I mean, if this rocket is static, it's just, I mean, and you put a horizontal, you can see the light ray as a horizontal line here. And if this rocket moves with constant velocity, then you have still a straight line with a certain inclination. But then if this rocket is accelerated, then what the guy inside the rocket is going to see is the bending of light. Obviously, this effect is enormously exaggerated in this picture. But using equivalence principle, in the same way that if the rocket is accelerating, right, using the equivalence principle, a guy in a uniform gravitational field will also see the bending of light. And that was the idea of Einstein put in this paper that he wrote while he was in Prague in 1911. Well, this is in German. I cannot read German, right? But thanks to this wonderful job that a lot of people have performed, we have all the Einstein papers translated to English. And we see here that in the last page, he computes how much would be the light bending of a star ray passing close to the surface of the sun. And this will be 0.883, in this case, seconds of arc, right? But we're going to see that this result has already been obtained before, although Einstein did not know that. But the great idea that Einstein had at that time was that it would be possible to be observed during total solar eclipses. And why do I say that the idea of light bending has been thought before? And because, especially, for instance, in Newton's OPTICK Treatise from 1704, in the end, Newton writes some queries. And the first query says, do not bodies act upon light at a distance and by their action bend its rays? So Newton had this idea. Cavendish, around 1784, remember that Cavendish was the guy that read the letter from John about the dark stars. But I mean, let's not go into this. But around the same time, so Cavendish performed the calculation about how much would be the light bending of a light ray passing close to the sun. Was not totally correct, but he obtained some result. Never published it himself. But in 1801, a German called Johann von Soldner not only had also this idea, but computed the amount that the light ray would deflect passing near the surface of the sun. And he obtained essentially the same result that Einstein would obtain around 110 years after that. But he concluded, since this is not known to happen, the perturbation by the sun can be neglected. He says, if one could observe fixed stars very close to the sun, one will probably have to take this into account. Since we cannot observe that, then we just forget about that. Because it did not occur to him the possibility of observing the light deflection during total solar eclipse. And that's why I said the main idea of Einstein in 1911 paper was the possibility of observing light deflection during total solar eclipses. This paper, by the way, has been translated to English and published in Foundations of Physics. Oh, obviously, I mean, this story is absolutely full of details, and obviously some people even attacked Einstein, talking about plagiarism and everything, I mean, related to this result of von Soldner. But I don't want to enter into the details. Obviously, I do not have to explain this to you, but just for completeness. So imagine that the star located here shines, and then there's a light ray that passes by the sun and is deflected and arrives on Earth. Here, we on Earth would look to the star and presume it would come right in a straight line, and then this will be the apparent location of the star for us. And think about a star field without the sun, right? That it will be like that. And when the sun is in the middle, then the stars would seem to be more apart from each other due to light bending. So as I mentioned, this was a very important result in 1911 from Einstein, the possibility of observing this effect during total solar eclipse. And he immediately did, just as Urbain Le Verrier did many time ago, decades ago, wrote to astronomers, in particular to astronomers from the Berlin Observatory, saying, look, try to measure this effect. For instance, observing the photographic plates taken during past solar eclipse, because many pictures have been taken during past solar eclipse, as I mentioned to you, looking for those intramercurial planets. And for instance, so it's interesting to go through the letters changed between, for instance, all these people, but in particular this letter from Albert Einstein to Erwin Freundlich, that was an astronomer in the Berlin Observatory. And in particular, this is a follow-up letter, right? Was not the first communication between them. And Einstein says to Freundlich, look, I'm very happy that you decided to dedicate yourself to this problem. And he says, if such a deflection does not exist, then the assumptions of the theory are not correct. So his theory would not be correct. His gravitational theory, although was not complete at that time, was talking about the assumptions from the beginning, they would not be correct. And he says, well, I mean, if you only had a planet larger than Jupiter, then we could observe this effect in Jupiter. But he says, but nature did not deem in her business to make the discovery of her laws easy for us. Very interesting phrases. And then it's going to come into play again an American astronomer, Charles Perrine, that as I mentioned to you before, had moved from Lick Observatory to Argentina to be the director of the Argentinian National Observatory that at that time was in Cordoba. And then suddenly Freundlich realized that Perrine was the person that had taken many pictures during total solar eclipse in the search of intramercurial planets. And he writes to Perrine a letter that by the time arrives in Argentina, Perrine was in Europe. And in fact, they end up by meeting in a train station in Germany, Freundlich and Perrine. And Freundlich had the idea also that it would be possible, it could be possible to measure the position of stars near the sun, even during daylight, right? Well, it was not possible with the technology they had at that time, but nowadays we know it's possible. Not, well, using electromagnetic waves, not in the optical wavelength, but in other wavelengths, okay? But then, I mean, this exchange of correspondence goes on between Einstein and Freundlich then writes to, as I said, talks to Perrine. Perrine said, look, the plates are in Lick's observatory. And then there is a change of letters between Perrine, Campbell, and Freundlich. And in this letter, Campbell writes to Perrine saying, look, as you know, Freundlich wants the plates. And then he said, well, but I was wondering if you're going to take the opportunity to observe and photograph the total solar eclipse that's going to happen in 1912 in October nearby Rio de Janeiro. And in fact, Perrine went there, as you're going to see in a moment. And Campbell sent the photographic plates to Freundlich by that time. And it came the time for the total solar eclipse of 1912. And then these are the main results that have been published in this Nature Astronomy paper early this year, together with Santiago Paulo Antonio. That, by the way, by the time we are now, he is in positioning himself to observe the total solar eclipse in Argentina. And more details are in this longer paper published in International Journal of Modern Physics, as I said. So this 1912 eclipse was even more important, I would say, in the time it happened than the 1919 total solar eclipses. This conclusion you can reach by seeing the number of astronomers gathered in a city, in a Brazilian city named Passa Quatro. Here you can see Eddington, Arthur Eddington himself, Charles Davison, that came to Brazil to observe this total solar eclipse, not to verify Einstein effect, but to look at the property, to study the properties of the solar corona. In particular, well, there are many astronomers, as I mentioned. So one of the astronomers was this guy here, that was Milan Stefanik. There's a very curious character. In fact, he has been not only an astronomer, but also the first Minister of War of Czechoslovakia. I don't want to spend too much time on this. But here you see the head of the Brazilian National Observatory, Morisi, that went to the port to for the arrival of the British team. In particular, you see here Eddington, Davison, and Atkinson. You see them all here also. Here's Eddington, Davison, and Atkinson. And I have just highlighted in yellow and red, respectively, the Brazilian and English astronomers that's going to be involved in the 1919 famous eclipse that we're going to talk in a moment. So this is the Brazilian settlement in Passa Quatro, Minas Gerais. I don't want to spend too much details into this. And this is the British settlement in Passa Quatro, Minas Gerais. They're having a tea in this near this Minas Gerais mountains, waiting for the time of the eclipse. But and you say, from all these astronomers that I mentioned so far, gathered together in that picture over there, does any of them was aiming to verify Einstein effect? And the answer is no. So who was there in Passa Quatro to observe it? Nobody, because Perrine and the Argentinian observatory team went to another city named Cristina, that, as you can see, did not change very much along the years, to observe Einstein effect, was the only team to observe the Einstein effect in 1912. And here is the settlement of the Argentinian group, observatory group. Here is in more details, and the cameras that were used to verify the Einstein effect are these ones. You see here the cameras in between the fog and some of the cattle around. But what happened in 1912 eclipse was very disappointing because it rained hard, not only in the day of the eclipse, but also in some days before and after the eclipse. So people were really, really very disappointed. You see here Arthur Eddington, that is not very happy, obviously, with the occasion. This was an important occasion. As I said, even the Brazilian president was there to observe the eclipse. This was Hermes da Fonseca, as you see, cited by Eddington and Morisi and other people. And this was they packing the instruments after this very muddy and rainy days. So, and you said, why? Well, why did this people did not take care and put different observation sites? And in fact, I mean, there was a second site to observe the eclipse in the city of, not in Minas Gerais, but in the state of São Paulo. But it also had extremely bad weather. It was almost a bad weather in all the stripe related to the observation of the total solar eclipse. As I said, many astronomers came from many places. This was the Chilean commission, because I didn't mention, but together, was working in Argentina that even Jacob Loeb, that was even one of the authors, the follow-up papers in special relativity, together with Albert Einstein. Well, you can wonder if Jacob Loeb was trying to measure Einstein's effect at that time, and my view is that he was completely unaware of that. He was more interested. He was at that time working as a professor at the University of La Plata, and he was more concerned with meteorological and air electrical measurements to be performed there. Well, the eclipse could also be seen as a partial eclipse in the city of Rio de Janeiro, where the Brazilian National Observatory was located. Many people went there, but it rained all day and no observations at all could be seen. Only the darkness, right, related to the total solar eclipse. And then let me just put out, so if you read the papers related to the works related to this eclipse of 1912, where you had in Brazil Eddington and Perrine, many people ask themselves, well, I mean, did they talk about Einstein effect? Well, they didn't talk in the observation sites because they were in different states, right? In different cities, in different states. But did they have the chance to talk during that occasion when they arrived before in Rio de Janeiro and anything? And I'm very happy to tell you that the answer is yes. And how do I know that? So I know that because in a letter that Arthur Eddington wrote to his mother, he wrote, the Argentinian and Chilean expeditions were going to Cristina, but the former, right, the Argentinian, Perrine and his 3 assistants came to dinner, it's written here, came to dinner with us at our hotel in Rio on Thursday. And we had a very jolly time. So they had the chance to talk. Obviously, they met in a dinner. I cannot say for sure if they talked about the Einstein effect, but most probably they talked about what they were going to observe, or at least try to observe. Well, so the story moved on, obviously, and Einstein soon realized that Freundlich received the plates, but could not conclude anything from the existent plates about this light deflection thing. But Freundlich had the idea that, as I mentioned, this observation could be made even without a total solar eclipse. And then Einstein wrote to some astronomers, this is a letter of Einstein to George Hale, and George Hale says, no, absolutely not. It's not possible with the technology, at least, that they have at that time. And then another total solar eclipse came in, the 1914 total solar eclipse. And it was difficult to raise money. And Einstein even said that, look, I can pay myself, he says. Should everything fail, then I will pay for the thing myself out of the little bit I have saved. So after careful consideration, just go ahead, he says to Freundlich, and order the plate, and do not let the time pass, and you do not perform the measurements because of any money problem. And so they're talking now about the 1914 total solar eclipse that could be observed from Eastern Europe, right? In particular from Ukraine and Crimea also. And the Lick Observatory team went to Ukraine, and the Argentinian team went to Crimea. But this eclipse would be in August 21st, 1914. But unfortunately, in the July 28, 1914, the World War I started. And then, I mean, all these expeditions were frustrated, in particular, the expedition by Freundlich, that as a German, was kindly invited, well, not so kindly, invited to leave the Russian territories because of the war. Campbell and Curtis, since they were American, they went to Russia, to Brovary, and set camp. And since North America was neutral in this phase of the World War, they could stay there, but they were clouded out, as they used to say. I mean, so the clouds didn't allow them to perform any measurements. Although they had the cameras, so at this time they were called Einstein-Vulcan cameras, because they would either confirm the existence of an intramercurial planet, either would confirm Einstein's effects. There are different explanations for the same problem, which is the irregularities observed in Mercury's orbit. So the path performed by Charles Perrine, now in Argentina, was a really long one, and he brought some cameras, but the cameras more specialized to observe the deflection by light deflection were with Freundlich, because Perrine sent them to Freundlich, and they would meet in Crimea, maybe even to perform the observations together, but it was not possible because of the war. Perrine even took some photographs, but it was a bit cloudy, and they were not the proper cameras to be used to this effect. But then we're talking about 1914 eclipse, and 1 year after that, in 1915, Einstein came up with the correct version of general relativity. In particular, you know that there were 4 communications in the Prussian Academy of Science, and in the a paper was published in the Annals named Explanation of the Perihelion Precession of Mercury by the General Theory of Relativity. And then he finds exactly the explanation for the precession of Mercury's perihelion. And then he was completely convinced. I mean, he says it is one of the biggest achievements of his life. He was so excited when he found this result that he could not even sleep in the following night. And for him, this question was solved. I mean, general relativity was correct. And in fact, I mean, so obviously it was really important to measure light bending, but for Einstein himself, as he declares, he was absolutely convinced that general relativity was correct because of the result of Mercury's precession. But one thing that he obtained is that the previous result that he had obtained in 1911 for the light deflection was wrong. So he had obtained 0.83 or 0.85, depending on the value of the constants he used. But the correct result obtained by general relativity is in fact 2 times this result. And then, I mean, again, I don't have to explain to you general relativity, right? And but this is really an amazing theory, and people would look at it and say, well, is really the nature so complicated? And the fact that was because, you know, the obtention of Mercury's precession was, you know, not an experimental verification of the theory, because, I mean, well, you could say that he has created a theory to explain that result, to obtain that result. So it's tricky, you know. Really, an experimental result was needed for that. And there was another solar eclipse in 1916 that could be observed in Venezuela. Well, the world was in war, so it was difficult for international teams to come. But that the Argentinians, they came to do some observations in 1916. Not Perrine himself, but astronomer of the observatory, and Cordoba Observatory, and he showed it. He took some pictures, but were inconclusive. And in March 1917, Frank Dyson himself published a paper saying, on the opportunity afforded by the eclipse of 1919, May 29th, to verify Einstein's theory of gravity. And then Perrine started a kind of moving the people from Brazil, especially Henrique Morizi, wrote a letter saying, look, you're going to be extremely important, as you were in 1912, and I plan to go there. But in the end, unfortunately, Perrine could not raise funds to go there. But before that, in 1918, there was a very nice occasion for light deflection to be measured in the United States, and in particularly in the house of the Licks Observatory, right? In the country of Licks Observatory. And in fact, they went there. Well, the main instruments were still, because they could not, one thing that I didn't tell you is that when the Lick Observatory team left Europe during World War, they were obliged to leave back their instruments. So they thought that the instruments will arrive in time for the observation of the 1918 eclipse. It didn't happen, and then they have to assemble in a hush, you know, other instruments, spare instruments, and the pictures they have taken were not conclusive. Well, this is tricky. Maybe we can talk about this afterwards. But I mean, some say that even they were more in the direction of Newtonian's result than in Einstein's results. But then in November 1918, the First World War ended, and kind of green light for future total solar eclipse, international future eclipse expeditions, and in particular, the next very nice occasion to observe the total solar eclipse was in 1919, May 29, where again was a very interesting site for observation, as well as Africa. And some expeditions were organized, in particularly the British expeditions aiming to verify general relativity. I've been involved in that. I mean, so this story you may have heard me talking about in previous occasions, at least some of you. So I would not go into details, maybe to leave some time for questions. But let me just summary that. So they organized the total solar eclipse 1919 total solar eclipse in Newton House in the headquarters of the Royal Astronomical Society, right? Mainly by Dyson, but Eddington also helped. And then they decided to make two expeditions. So one to Brazil and other to Africa. And they went on board of this ship. This is not an arbitrary ship. It's the ship they went in is the Anselm steamer. And they navigated from England. Then after a quick stop in Lisbon, they went until Madeira Island. And then the two teams of astronomers separated. Part of them coming to Brazil and the other going to Prince Island in Africa. And to Prince went Eddington and Cottingham. And what did they do to make the observations? So they took essentially the objective lens of English observatories. In particular, Eddington and Cottingham took with them the objective lens from the Oxford University Observatory. And this was the house where they stayed and made the observations in the back of this house, in the yard of this house. And so this, in the paper they published it, here is the star field of the instruments they used to record. And these are the stars, the 13 stars they were prepared to record and to measure the displacement. The team from the Eddington and Cottingham took 16 photographs, but it rained a bit and it was very difficult to take any measurements out of them, and they used only 2 plates to conclude that the value was 1.61. So in between 85 and 1.7. So in between Newtonian and the correct Einstein result, as we know it. So they needed more, because only 2 photographs taken through the clouds was not enough to a robust conclusion. So they had to wait from the results from Brazil, right? And in fact, as I said, another British team went to Brazil in the same ship. So the ship that left Cottingham and Eddington in Madeira followed the path to Brazil to make the observations in Sobral in the state of Ceará. But they, in fact, this ship left the astronomers and the equipment in the city I'm talking to you now, which is the city in Belém. And essentially, this is the reason I'm here today telling the story, because it involves my city and I became just passionate about the subject. And I even found an article published in the first page of the newspaper called Estado do Pará, that talks about that passage of the astronomers, Einstein theory. They took 19 pictures with one instrument and 8 pictures with another instrument. I should say that to Prince Island in Africa, the astronomers took only one instrument, just like this. But to Brazil, they took 2, and in fact was the second one, the older one, the auxiliary instrument that made the main observations. And so this is a long story. So the main instrument did not work very well, and it turned out that was the auxiliary instrument that gave the most important measurements that confirmed Einstein's result. But well, I mean, and then the results, this story, I mean, you all know, right? I mean, and has been told many times, in particular in the conclusions of the paper. It's written precisely that in summarizing the results of the 2 expeditions, the greatest weight must be attached to the 4-inch auxiliary instrument that came to Sobral, right? And I mean, I have talked about this story even in Maso Grossman. I think Adrià, that is in the audience, was there too, and many people looked at me. I mean, kind of surprised, and that's why I decided that I should write something about in an impact journal like Nature Physics. And then I looked for Daniel Kennefic, and we wrote together a paper in which we tell the story in details. I would just, because of time, I would just jump some details and converge to the end of my talk. And as I said, so the conclusions were announced, were published in a paper that was publicly announced in November the 6th of 1919, and it suddenly turned Einstein into a pop star, right? This is the Times in London publishing the news about, even invited Einstein to write a paper himself. The New York Times in the following days also published an article about Einstein's triumph. And some years after that, Einstein got the Nobel Prize in physics. Some people say it was not because of that. Well, I mean, if you read carefully what's written there, for his services to theoretical physics, especially for the photoelectric effect. But obviously, his service to theoretical physics includes general relativity. Einstein visited Brazil sometime after that. He even wrote a note saying that his ideas were confirmed by Brazil's sunny sky. I mean, this was published in the preface of the proceedings of a conference we had in Brazil to celebrate. So, well, I mean, in 2019, in the centenary, we celebrated the centenary in many places. One of these places was the Príncipe Island itself in the west coast of Africa. You see here the Portuguese and other international physicists that went there to celebrate. Here is even the president of Portugal in this event, promoted mainly by José Lemos, that you all know. And here is Carlos Herdeiro that gave me this picture of him sitting in the precise observation site that Eddington and Cotting and performed the observations. Obviously, we celebrated in Sobral as well, and here we had this big cake. Here we have the president of the Brazilian Society for the Progress of Science. Here we have our astronaut. Our Ministry of Science and Technology. And it was funny because at that time, for instance, well, you can ask, do really people know about Sobral? If you ask me, I can tell you some stories about that. But one interesting story is that some days before that, an interviewer from a reporter from the New York Times just made me a telephone call, and she said, so you're going to tell the people in Brazil the importance of the observations performed in Sobral? And I said, no, this is common sense in Brazil. We all know this in Brazil. I need to tell people from other places. So we had celebrations in Sobral. Even a statue of Einstein, very popular one, was put there. There was the re-inauguration of the museum. We had this video mapping that's very beautiful. And even the instrument, this was amazing. The instrument that these are the lens, and this is the celostat that were used to perform the measurements, were brought there by Tom Ray. We had a celebration in Valencia where you are hosting this event. So this is the opening ceremony. You see here Tony Font and many people in the audience. This was the opening talk about that mentioned the first experimental verification in 1919 by Clifford Wheel. And this, you can see many people in the audience, many important people in the audience. As you can see, for instance, Andrea Guest sitting here just beside Carolina Benoni, that's going to give the last talk in today's session, right? I don't think Carolina knew that at that time. And here is me in the end of the talk by Clifford Wheel, asking him, for instance, if he knew about this Argentinian attempt to measure that I just told you today. And here was this special event in the Botanical Garden of Valencia University, where we had this talk. Here's Gonzalo, and there was a show, an exhibition, a dance exhibition, astronomical observation. Here's the guy picturing the moon. We had a celebration in Belém that some of you were, and it was very nice. And coming to my final remarks, so we had the triumph of celestial mechanics until the problems in the motion of Mercury. And we had these eclipse hunters that went all over the world to try to figure out the problem. We had the first attempt in 1920 to measure Einstein effect, and then in 1919, the successful attempt that ended up in transforming Einstein in a world celebrity. Here is the person of the century. Well, I mean, general relativity goes very well, was responsible to the 2017 Nobel Prize. Space physics was also responsible to the 2017 gravitational waves, 2019, and now 2020 for black holes. And I won't talk about this because you are in this audience is all aware of this year's Nobel Prize. There's more things to come, to be expected. As you know, there are black hole analogs to be checked in laboratory, and general relativity is very important in our daily lives because, as you know, any smartphone uses general relativity to give you your correct position. And yes, we do basic research, and you may not think that it's important, the common citizen, but it really is, and it has to do with one thing that you use almost every moment, right? And then I have to acknowledge, I showed here many images that were given to me, granted to me by many archives and museums distributed all over the world. And I should also thank the people that sponsor my work. Thank you very much for your attention.
Thank you, Luis, for your nice talk. I would like to have a button just to clap, just to mark the end of the talk, but something in progress. We will implement it soon. Okay, it's been
no problem.
Very complete and very nice to learn all these things about the history of general relativity and the measurements, the verification of the theory. It's really amazing. So now people are clapping in the chat. So if anybody has a question, you can raise your hand or write in the chat, okay? And in the meantime, I'm very impressed for your talk and the many details and original pictures that you are showing, okay? Do you have an estimate? Because I guess that many of those pictures are not freely available on the internet, right? Are they?
Yes. No.
Yeah.
I had to write to many observatories and museums, and some of them, for instance, obviously, it's tricky, but sometimes, I mean, there's money involved in keeping these pictures, so it's natural that every here and there you have to pay a certain amount for the reproduction of these of these photographs. You have copyrights and everything's to respect. But I think that for educational purposes, it's okay to show them. But I think it's really, I mean, it's impressive the amount of time you put to, because, I mean, people have heard, for instance, to get a copy of this letter of Eddington to his mother, telling that he effectively met Perrine. This is amazing, isn't it? So people, well, they have been in Brazil. Did they meet? Right? I mean, this is something that, I mean, is answered by a letter that somebody wrote to his mother. It's really, really amazing. And I mean, where the instruments brought to some place, and then you have to go and check the pictures. So the pictures, I'm passionate for pictures, right? But they really, really help you to put the story together, to put the correct story together.
Yeah. And you said that you had to pay sometimes for the pictures. Do you have any estimate of how much you spent in preparing?
Well, I mean, I think it's not much. Yeah, it's not much when you compare to I mean, the time you put in this thing. If you think that your time is money in some sense, right? Well, because you have to think that in fact it's very difficult to keep these pictures. For instance, in Brazil, you could ask, where are these pictures in Brazil? So I tried to find if there were any pictures, for instance, as I have shown to you, right? I mean, these pictures were mainly from Brazil sites. You see these pictures I'm showing now, right, from the city of Cristina, right? They were taken in Brazil, but they were not in Brazil. They were found in a museum in Cordoba, right, in Argentina, where Perrine was based. In this case, I did not have to pay anything about these pictures because Santiago Paulo Antonio was the responsible to find these pictures, and he had published some of these, and some of these we have the happiness to publish together in this Nature Astronomy publication of this year. And in this paper, we have also pictures that have never been published. Some, mainly the ones that show the Einstein cameras in the Eclipse expeditions of 1914, the Lick observatory images. And for instance, you know, maybe the only picture known, the only known picture about the 1919 eclipse is this one, right? That has been published in Arthur Eddington's book, right? And this picture is not available in Brazil. It's available in a British museum, although it's from Brazil. But you know, one very interesting story that I didn't mention is that there are some pictures, right, taken in Sobral during that occasion, and these pictures were taken by an American scientist that went there to perform some magnetic and air electricity measurements. So here are the pictures that he has been taking of these instruments, and you see the houses where they stayed can be seen in the back. So it's even, I mean, so Sobral, for instance, there's also the social history behind it that I didn't mention. To a strong period of drought, and it was very hard to obtain water. The water was taken from holes made in the bottom of a dry river and then carried over these animals to be distributed in town. So this is really, really amazing. For instance, this is a British hut, so with the instruments inside. So this is the house where they stayed during the measurements. And this was a completely unknown picture before we published this in our papers, right? And this picture was taken between the two measurements, because first they took some pictures during the eclipse, but they have to take the secondary or auxiliary pictures of the same star field without the sun, then to compare to see if there were star displacements, you see? So this is a very interesting picture taken in Brazil soil, but was in a library in the United States, in the Carnegie Institution Library. And then if you ask me how I ever had the idea, you know, to write to that institution and then to find the person that was responsible for that, even to the families, because in the search for these pictures, you have even to write to the descendants of these people, right, to try to get some information out of them. And it is really an investigation. It's really research, although a very different kind of research in many aspects of the, let us say, the computational research that we used to do in our day-by-day tasks. But it's also a research, and a respectful research, and a very interesting, and that gives you many pleasure. Anyway.
Yeah, really, really interesting. Yeah, amazing. So and now let me ask some technical question about the, since you explained, gave many details about the history of observing eclipses and the Vulcan or the Mercury, intramercury search for new planets. So I was thinking there were many available pictures of that area near the sun. So when was the technology? I guess that there was necessary. You mentioned that at some point it was not possible to measure the deflection, the amount of deflection needed by the theory to check general relativity. So at what more or less when was the technology able to measure
By the way, I'll get to that. I was even checking the Brazilian plates, because you have, you know, the Brazilian plates with the sun, the eclipse, to try to find stars here. But this is another story. But let me show you. So as I mentioned, you see here, to answer your question, so you see here So the problems, when the people were looking for intramercurial planets, they were taking pictures, right, of the surroundings of the sun. But normally they would take just a part of the sun and the star fields around, you see. And for this kind of measurement, you need to have the sun all included in the picture. For that that diagram that I showed you, I think it's better to understand. So you have to make the comparison measurements. That's the problem in using many slides. Yes, this one. So it's very important for you to, so you have to measure the distance between the two stars, right? When the sun is in and when the sun is out. So you really need a field, a photographic field, in which you can see the sun and the stars, right? But the whole sun. So preferably stars in the two sides of the sun. So this is was only achieved in this, because when you are looking for intramercurial planets, so you just fix the sun and try to find the stars or the planets, right? The presumable planets around. But then, and then what's the displacement? So this, so maybe your question was also this displacement of 1 second of arc. So is it, did they have the precision to that? So they just got the precision. So for instance, there was a huge project going on to photograph the whole skies, you know, with instruments around the world, mainly in Europe, right? But also in the south. And this a project that also involved Perrine, or tried to involve Perrine in a sense, to make a complete survey of the sky. And it was important even for parallax measurements, you know, even to infer distance of objects, you know, to have precise measurements of the distance between stars, you know. And then it was just the time. So it's impressive, if you like to think from this point of view, that at that time in 1919 or around that time, they have the technology that was precise enough to get to the conclusion of this displacement of 1 second of arc. So it's amazing. So I mean, there is I think it's from Karl Marx, but I'm not sure. People say is that you know, a problem just comes up in a society when the society itself has the technology to solve, as if, you know, problem and possibility of checking or solving it, right, is more or less simultaneous. Obviously, the problem of Mercury, you can think of the problem of Mercury, was pointed out in 1859. But it was less between 1 century, we're talking about around 50 years, for this problem to be solved, you know. So, and this is also because, you know, if you don't have the technology, so you put all your efforts to develop your technology and just to make it updated with the things, for instance, gravitational waves, right? People try to measure gravitational waves. It took 100 years, and that's okay. But you know, one thing that's very amazing, how fast they produced the vaccine, okay, of the coronavirus. If you think about, you know, it was 1 year time. It's amazing how in nowadays technology, we were so fast as to develop a vaccination for a disease that in principle could injure much humankind.
Okay, thank you so much. So I think it's time to finish this discussion and then give pass to the next speaker. So, Luis, again, thank you so much for waking up so early today to give us this very interesting talk. Okay.
My pleasure, Gonzalo. Thank you very much for you and everybody that's
the meeting as much as you can. Okay. Thank you.
Thank you.